All right, so 3 more students. So I'm so sorry for that. I wasn't able to monitor the time again. So we'll just wait 1 or 2 more minutes for the others. So if you guys have a question or clarification, so this is now your time to ask that question. All right. So the other two will just catch up to us. So let us now continue with our discussion. So again, I apologize for that one. I wasn't able to monitor the time of our meeting. Anyway, so where are we now? So what I'm trying to say a while ago here is that the elements of this attribute should be equal with the elements of this attribute, regardless of the arrangement. All right. So again, if ever there is one element that cannot be found on the other tables, like for example, again, this one is 01180, but on the other side, this one is 01181, then you won't be able to combine those two tables. Okay, you will have an error for doing that one. All right. So if you're going to check, if you're going to check, okay, all of the keys for the ID number and then PID, they are all the same. All right. So in that case, we can now combine those two tables by this format. So we have the join operator and then player. So this is the name of this table. And then ID number is equal to PID. Yeah, this is the link attribute with each of those two tables. And then the name of the other table, which is assignment. All right. And then another thing here is whatever is the format of your first table, okay, will be the one that will be followed for your combined output or combined table. All right. So as you can see right here, 22012 first. So it's now being followed by the PID, which is 22012. Okay, blue socks, etc., up to the last one, which is 01180, which is the same with this one, 01180. All right. So did you guys get this one so far?
Yes, sir.
Yes, sir.
All right, very good. Now let's have a short exercise. So consider the following tables. So do not mind the elements inside of it. Just memorize or take a look on the name of each of those tables. So we have employee, department, buyer, and then supplier. Then the next thing here is their attributes. So for employee, we have ID, name, manager, and then department is department and then manager. Then for buyer, we have the name and then part number. And then for supplier, we have the department, part number, and then quantity. All right, so here are the questions. And then again, here are the uh, tables that we have in here. So we have 4 tables and then their own attributes. So number one question here is find the names of all employees. So do not include any managers. So we are now filtering a certain table or a certain attributes. So anyone wants to answer number one? Find the names of all employees and do not include any managers. So if you're going to take a look on this table, so we have this employee and then there is no other table which is employee. So we're going to retrieve the names from this table which is employee. Okay. So I will answer number one and then I will let you guys answer the following questions. So project. So the table name is employee, followed by the attribute that we're going to display. So we're only going to display the name. Okay. So it says here, do not include any managers. So we're only going to display names. Okay. And if ever you're going to answer ID and name, so I will also accept that one since it says here that the only one that we should not include is the managers. But we can include the ID and then name for that. Okay, since you can say that we should not include the ID. So here's the answer for the number one. So did you guys get this one? Oops. Very simple, right? But then again, do not use the word project, okay? So you must use the symbol pi employee and the name. So did you guys get this one for the number one?
Yes, sir.
How about number two? Find the names of all managers. Filter only names of managers. Anyone?
Sir, project department manager.
Right. So as you guys may have noticed, we have manager here and then we also have manager here. So regardless of those two, it's okay. Okay, because as you can see, bote is and then another bote here, so it is only counted as one. Okay, so again, let me just repeat when it comes to combining or when it comes to projection. So it says here duplicates will be eliminated or duplicates are eliminated. Okay, so that is why you can project from the employee and then the condition or the call this one attribute manager. And then for the department, we have table name department and then manager. All right. So Bote, Campi, Labio, and then Pablo. So the same as well. All right. So very good for that one. How about number three? Find all part numbers. Filter only part numbers. So as you can see right here, we have buyer and then supplier. So if we're going to choose between those two, then that's the time that we have to compare now. Okay, because as you guys can see, we have four distinct part numbers in here, but in supplier, we now have five distinct part numbers. So we have an additional 772. Okay, and it says here, find all part numbers, filter only part numbers. So it says here all, then we must include all of the part numbers. So where are we going to retrieve that attributes? Is it from supplier or from buyer?
Supplier.
Buyer.
All right, so supplier. So project supplier, and then open and close bracket, and then part number. All right. So did you guys get this one for 1, 2, 3?
Yes, sir.
All right, so again, if you guys are confused in some parts, let me know as soon as possible, okay? Don't be shy to ask. Right, so we have a continuation here, 4, 5, 6. So find all names of buyers, filter names only. Anyone who wants to answer this one? Find all names of buyers.
Project buyer, sir.
Project, okay? Project, buyer, and then,
Name.
Name.
okay, simple as that. How about number 5? Find the names of all employees who are managed by Bote. Okay. What is the next one?
Select.
Yes. So this time we're now going to use the word select because we have a condition here wherein we have to choose the tuples which is only being managed by Bote. So close and open parenthesis and then select from what table?
Employee.
Find the names of employees. Employee. And then condition.
Manager.
So manager
Equal to bote.
equals to Bote. What else?
Name.
Of course, we're only going to project the name. Right? So from here, it will process this one first. So it will select employee who's being managed only by Bote, and then it will only display the name from that tuple. Right? How about the last one? Find the part number being managed by Pablo, filter only manager, and part number. All right, so let me just put it right here. Oops. Okay, so here's the question. Find the part number being managed by Pablo and filter only manager and part number. Anyone who knows what is the first step?
Join.
What is that?
Sir, mag-join muna.
Right, very good. So we have to join them as one table first because we're trying now to filter the manager and then the part number. Okay, so we cannot do that one in one projection or selection only. Okay, so we have to combine them first. So as you can see, we can combine them since we have the same elements for department and then department. Okay, so duplicates will be eliminated. So the symbol for join is this one. So cardinality and then X or absolute X. And then the name of the first table is department. And then what is the link attribute? Link attribute, guys.
Depth, sir.
Department is equal to department, right? followed by the name of the next table, which is supplier. All right. So of course, this newly combined table will form a new name. Okay. So let's just assume that the name of that new table is department supplier. All right. So from there, we can now project and select. So the name of that table now is department supplier, followed by the condition wherein find the part number being managed by Pablo. So manager is equal to Pablo, and that's it. Then we're only going to display the manager and part number. So here's now our answer for the number 6. So we're going to combine them first. And then once we're done in combining, we're going to arrive at the new name of that table, of course, which is now this one. So select that table, combine table. And then the condition is manager is equal to Pablo. And then we're only going to display manager and part number, just like what this question is asking us. So filter only manager and part number. So were you guys able to follow?
Yes, sir.
Yes, sir.
All right, very good. So once you're done in understanding all of those concepts and examples, then you may now start in answering this quick number 1. Okay, so we have the same tables, employee, department, buyer, supplier, but just different questions. All right. So you can do this one in Microsoft Word or handwritten. Then again, if you're going to do this one handwritten, please write legibly, right? So I will leave this one to you now, since we don't have enough time, so we'll just skip this one. And then if ever you have a clarification from those questions 1 to 5, then just ask me as soon as possible, or approach me right away, right? So the next one here is union operator. So just like what I've said a while ago, if we can combine two tables side by side, we can also combine tables vertically, okay, or in one line only. So here's the condition before you can combine or before you can unite two tables. So they must have the same attributes with duplicates removed. Okay. So if they don't have the same name of attributes, then you won't be able to perform this operator. All right. So as you can see here, append the content of relation R2 to relation R1. So we can append this one right here if only we have the same attributes. Just like this, we have ID number, we also have ID number on the other side. We have the name, and then we also have the name on the other side. So in that case, we can perform the union operator. And then here's the syntax for that one. So R1 to R2. So again, whatever is the first table, then that is the one that will be at the top. And then whatever is the second will be just follow to the first one. All right, so we have here from top to bottom. So they just simply combine, okay, vertically. All right. So were you guys able to understand this one?
Yes, sir.
Yes, sir.
All right. How about the others?
Yes, sir.
Yes, sir.
Yes, sir.
All right, very good. So ngayon ko lang narinig si Mr. Mosquela. Right, so I hope the others were able to follow also. So if we have union, we also have intersection, but in here, instead of combining, we're just going to get the common elements on a certain attributes. Right, so the same concept, they must have the same attributes, but different action. So as you can see right here, we have the same attributes, and then if you're going to perform intersection, it will only get the same elements or the same tuples. Like for example, we have 10,000 and then 20,000 for ID number. So we have the 10,000 here and then the 20,000. So as you can see, it only displayed those two. So 10,000 Aquino and then 20,000 Larga. All right. So did you guys get this one?
Yes, sir.
All right. So the symbol for intersection is just an inverted. Okay. So we also have difference. So this one will return rows of relation R1, but not in relation R2. Why? Because whatever is the first table, that is the one that will retain, and then whatever is the second one will be deducted on your first table. So relations R1 and R2 must have the same attributes. So the same concept with union, intersection, and then difference. So all of them must have the same attributes. All right, so as you can see right here, R1 minus R2. So R1 first, and then followed by the R2. So if you're going to do this one, you're going to retain the R1, and then you're going to remove the common elements from R2 to R1. Like this first example, we have pitch M minus non-pitch M. So pitch M is this table, and then non-pitch M is this table. All right, so from there, as you can see, we're going to retain the pitch M for the table number 1. So 933184341011180. So the common elements from those two tables are again the 80,000 and then the 10,000. So, sorry, 10,000 and then 20,000. Okay, not 8,000. So it will only retain the 93831 and then the 84341 and then 01180. So those two were removed. Okay, eliminated. Oops, eliminated, eliminated. All right. So the same process, but just a different format. Again, R2 minus R1 or non-teach M minus teach M. So from here, we're going to retain this table, and then we'll remove the same elements between those two. So as you can see, 10,000 is their commonalities, and then 20,000. So we will retain the 90,000, 80,000, and then 50,000, just like this. So this is the result for R1 minus R2, and then this is the result for R2 minus R1. Were you guys able to follow when it comes to difference operator?
Yes, sir.
Yes, sir.
All right, so this
Yes,
one is
sir.
basically the same with our set operations before, but this one now is in a form of table instead of just in a form of set, okay, or Venn diagram. All right, so we also have here functions. So this one is another relation, but as a special kind of relation. So this one takes an element from a set and maps it to a unique element in another set. So basically, it's like the root and then what is now the result of that root. Or this now is the domain and then what is now the result of that domain when it becomes a range. Or just basically, this is the pre-image before it becomes this image. Okay, so again, in function, we have a certain formula that will be given to you. So as of now, okay, for this example, this function is this one, f of x is equal to x squared. So the pre-image is 4. If you're going to follow this function, it will just square this number. So 4 squared is 16. So as you can see, the pre-image is 4 and then the new image is 16. So we have a lot of ways to read this one. So this is the pre-image of 16 and then this is the image of 4. Anyway, so it's just basically domain and codomain or domain and range. So let's have more examples. So this is another a function. So we have the domain and then the codomain. So in here, we're just saying that Alice has a grade of A, Bob has a grade of C, Grace has a grade of A, Dave has a grade of F, and Emma has a grade of B. And as you can see, this one is a class grade function. All right. So later on, we will see more examples on what are the valid function and then not a valid function. Then we have another example here wherein we have the pre-image, just like what we're talking about a while ago, and then the image. So the pre-image of this letter A is 1 length, and then for BB we have 2 lengths, for CCCC we have 4 lengths, and then for DD we have 2, and then for E we have 1. Okay, this is just basically a string length function. All right, so did you guys get this one so far?
A little, sir.
A little. Okay, so let's have more examples for you guys to appreciate what is this function all about. Okay, so again, we have the pre-image and then the image. So this one can be read by this one. So image of F Alice is A. Means what is the grade of Alice? It is A. Okay. Another one here is pre-image of C. Pre-image of C is Bob. Means who got the C grade, which is Bob. Okay. So you could say that they are in relation. Okay, to make it short, relation function. So Alice is related to grade A, Bob is related to grade C, etc., etc. And then the term for pre-image is sometimes called domain, and then the term image is sometimes called the codomain or range. Okay, X going to Y. All right, so let's have more example when it comes to a function and then not a valid function. So we have here the minimum rule when it comes to function. So function f is from x to y, is a relation from x to y having the properties. Number one, the domain of f is x. Okay, so when we say domain, it must be your x. So it cannot be your y. So it's always from x to y. So it cannot be from y to x. That is a different, call this one, different relation anymore. Okay. So when we say function, it must be from the domain to range or from the x to y. We have another one here is it must have one directed edge for every domain. Okay, meaning all of your domains must have a partner. Okay, like for example, this one. Your domain number one has a partner, one partner only. Take note, it cannot have two partners. So your domain number two has also a partner. Domain number three has also a partner. Okay, so if you're going to imply this example to those properties, so number one, domain of f of 1 is equal to 1, 2, 3. So this is our domain, this is our codomain. Okay, so as you can see, our domain is 1, 2, 3, which is originally came from x. Okay, so the rule number one is already followed, okay, or correct. So number two, only one directed edge of every pre-image. So as you can see, they only have one directed edge on every pre-image. If ever there is another one, like 3 going to 3, going to B, this one is not a valid function anymore. Okay, so those two properties must met. Okay, those are our minimum conditions. Right, so were you guys able to follow now at least 50% when it comes to function?
Medyo, sir.
Or just 10%? Anyway, okay, that's okay. I would like you guys to be honest so that we can discuss this one a little bit more. Okay, so we have another example here wherein we have function 1a, 2a, and then 3b. So let's see if this function is valid using those two properties. So from x, we have a total of 4 elements, 1, 2, 3, 4. And then going to y, it's ABC. So take note, This one is correct. That is the first thing that you need to check. It should be from x to y. So if ever we have here from y to x, this one is not a valid function anymore. All right, so that is the first uh, requirement that you need to check. Second is the function. Okay, so what are the relation function we have here? We have 1a, we have 2a, and then we have 3b. So as you can see, number one, the domain of f is x. So the domain of f sub 2 is equal to 1, 2, 3 only. Why? Because the fourth one is not connected on the other side. Okay, meaning this one now is not under the element of x. Okay, wherein if you're going to take a look at this one, 1, 2, 3 for function 2, but with your x we have 4. Okay, so that is why this one is already not a valid function. Another one here is has one directed edge for every domain. So take note, we have the term here, every domain. So meaning all of your domains must have a partner. Okay, so take note, partner, not partners. We only need one partner. Okay, so this one can go to A, can go to B, can go to C. Okay, so any of those, as long as just one. Right. So as you guys can see, this example number 2 is not a valid function. So were you guys able to understand it now? At least 50%?
Somewhat.
Somewhat? Somehow? Some way? Anyway, so just memorize this one. Then you will now be able to verify whether that function is really a valid function or not a valid function. Right, so let's have more example. So this one is another example of call this one a valid function. So we have here 1a, 2b, 3c, 1b for your function 3 from the coordinates or from your domain 1, 2, 3, and then codomain ABC. So 1, 2, 3, ABC, so no problem. And as you can see right here, from the function or relation 3, we have 1a and then 1b. And then from there, you already know that this one or this domain has two partners. So this one is not a valid function because it has two directed edge for pre-image, wherein it should be only one. All right. Though the domain is correct, okay, number one property is correct, but for the property number 2, wasn't able to follow or abide the condition. Right? That is why this example number 3 is not a valid function. So, were you guys able to follow or understand it now at least 70%?
50, sir.
50%. So do not find the partners of domains. So some of them can be, or some of them can not have a partner like this one. It's still okay. Like if ever this one is connected with D and this one doesn't have a partner, it's okay. This one is still a valid function. And another thing here is if ever, let's say, 1A, 2A, 3A, 4A, all of them is connected in one codomain, it's still okay. Okay, this one is still a valid function. What we're trying to verify here is just the domain. Okay, so the domain must have one partner only, and then the domain must all have a partner. All right, and then actually this one is quite useless as long as there is no repeated partners for domain, then you're good to go. All right, so yeah, just analyze these examples, then you will now be able to verify whether this 1, 2, 3, and 4 is a valid function or no. So this one is super quick to answer. So you can do this one in Microsoft Word, right? So this is your Seatwork number 2. Just tell whether this function is a valid function or no, right? So we have 4 numbers for this one. All right. So any clarification so far when it comes to secret number 2?
Answer.
Wala po.
All right, so let's move on to the next one. We have your vertical test for a function. So this is just a way of showing whether the graph or coordinates of that function is a function or not a function. Okay, so if the vertical line cuts the graph of a relation in more than one point, then the relation does not represent a function. Okay, so why is that? Because it is already having too many x coordinates. Okay, like for example, this one. Let's just say that this one is the coordinate 1 and then 2. Okay, so as you can see, we have coordinate 2, let's say 2, -1, which is this one, and then we have another one, which is, let's say, 2, +6. So this is just an assumption. So 1, 2, 3, 4, 5, 6. And then we have another one, which is 2, say 10. Okay, so as you can see in this function, we have 3 the same function wherein they are now not following the property of our function to be called just a valid function. Okay, so this one now has one more directed edge going to the other, right? And as you can see right here, the other one here only hits one coordinate, so 1x only. So this one is a valid function. Okay, so not a valid function, valid function. All right. So were you guys able to follow now? When it comes to, or just by looking the coordinates?
Yes, sir.
Yes, sir.
All right. So
Yes,
let's
sir.
switch to the secret technique. Okay. So this is the fastest way in checking. So you can actually disregard this one. Okay. Just do not look on that one. You can just take a look on the x domain and then y domains. Okay, so we have 1, 2, 3. So check. Do we have that? Do we have that 1, 2, 3 on this function? So 1, 2, and 3. All right. So we're good to go. And how about the repeated elements for the domain? Okay. So as you can see, we have repeated elements for the domain, which is 1. Wherein, if we have repeated elements, this one now is not a valid function. All right. So that is the easiest way for you to be able to verify whether this function is really a valid one or not. All right. So I hope you guys were able to get that secret technique, okay, without looking with our graph. So any questions so far? Or clarification?
Wala po.
All right. So we'll just continue the rest since we don't have enough time anymore. Okay. So I'll end this one now and see you guys